welcome to this new activity, which is about an application to economics. So a company manufactures memory chips for microcomputers. Its marketing research department, using statistical techniques, collected the data shown in the table, where P is the wholesale price per chip and which X million chips can be sold. Using special analytical techniques, regression analysis, an analyst produced the following price-demand function to model the data. So we have here an expression of the price as a function of the quantity X. Okay, so this is what we call the price-demand function, and this price-demand function is available only for X between 1 million and 20 million. Okay, so be careful. Our domain for the price-demand equation is the interval 120 for X. Okay. The first question is plot the data points in the table and sketch a graph of price-demand function in the same coordinate system. So here we're gonna take a coordinate system. Okay, you can draw your own coordinate system and plot the data points shown in the table. So you're gonna put the ordered pairs XP. The first one is 1, 72, which is around here. Okay. The second one is 463, so 4 is here. And we have 60, 63. It will be around this position. The third one is 948. 48, so around this position. Fourth one, 1433. 1433. So we have here 30, 35, so around here. And the last one is 2015. 20 for X, 15 for Y, or for P. So we have our points. Now we're gonna try to join them to get the graph. And here, if you try to draw a line, you will get your line passing through the points. And is it expected? The answer is yes, because our P of X is a linear function. Okay? Now we're gonna move to the next question. What would be the price per chip for a demand of 7 million chips for a demand of 11 million chips? Remember that we have P of X equals 75 minus 3X, and we're gonna use this price demand equation to determine the price for different quantities. So P of 7 is 75 minus 3 times 7, which is 21. So we just substituted X by 7 here. Keep in mind that X is million of chips. So here, 7 million chips. You replace just X by 7 and you will get the result, which is $54. Now for 11, P of 11, the price at 11 million chips is 75 minus 3 times 11, which is 33. And the result is $42. Now we move to the third question, which is write the company's revenue function and indicate its domain. Just a quick reminder here, the revenue is always the quantity times the price. And our quantity here is represented by the variable X. Our price is P. Okay? So our revenue function is R of X equals X times P. And we can substitute P by its expression, which is 75 minus 3X. We're going to obtain X times 75 minus 3X. When you expand this expression, you will get 75X minus 3X squared. Okay? Of course, you can keep your factorized expression if you want. Okay? Now, the second part of the question is indicate the domain of the revenue function. Since the price demand function at the beginning here is defined for X between 1 and 20, we have to keep the same interval. because the revenue function will inherit the properties of the quantity and the price values or variables, okay? So please keep in mind that the domain of the revenue, also the domain of the cost, and the domain of the profit will be the same as the demand equation domain, okay? So let's do this. Let's just write that our domain here is not R. We have a polynomial function, but the domain is not R because we are in an application and it's a little bit different. So the domain will keep the same domain as the price demand equation. So it's 120, the interval, the closed interval 120, okay? Now the next question is complete the following table computing revenues to the nearest $1 million. So here it's very easy, you just plug in the x in the revenue function, 75x minus 3x squared, and you compute. So for x equals 1, you obtain 75 times 1 minus 3 times 1 squared, which is $72. Now you can complete, of course, the table for the different values of x, and using your calculator, you will obtain the following values. So $252 for x equals 4, 408 for x equals 8, for x equals 12, you will obtain 468, for 16, you will obtain 462. I already computed these values. I'm not doing this mentally, but I already have the values, okay? So for x equals 20, you compute the revenue and it's 300, okay? So it's easy, you just substitute the x here by the corresponding value in the expression of the revenue, okay? Now we're gonna move to the next question. Here it's about the cost function. So the financial department for the company established the following cost function for producing and selling X million memory chips. You have C of X, which is the total cost, equals 125, which represents the fixed costs, since it's a constant cost, okay, fixed costs, plus 16x, and this part is the variable cost, okay? This is variable cost. But anyway, we have our function C of X. The question is, write a profit function for producing and selling X million memory chips and indicate its domain. Again, a quick reminder about the profit definition. So the profit is equal to the revenue minus the cost, okay? Here we have our revenue function, we have our cost function, so we can compute our profit function. Capital P of X, which represents the profit, is equal to the revenue, R of X, minus the cost, the total cost, which is C of X. Of course, we're gonna substitute the two functions here, the revenue and the cost, by their expressions. Remember that R of X is equal to 75x minus 3x squared, minus the cost expression, but here pay attention to put the brackets. Since you have a minus sign, you have to keep the brackets to avoid mistakes. Or you change the signs inside the expression, okay? So plus 16x, I will keep the brackets for the moment, and then I will remove them in the next line. So here, if you try to simplify this a little bit, you're gonna obtain 75x minus 3x squared, minus, now we remove the brackets and we inverse the signs inside, okay? So 125, pay attention to this, minus 16x. Of course, we can group the similar terms. Here, I'm gonna start by writing the quadratic term, minus 3x squared. We have 75x minus 16x, which gives plus 59x. And at the end, we have a constant, which is minus 125. And this represents your profit function, P of X, okay? The domain of the profit is, as I said, the same as the price demand equation. So the domain of your profit function will keep the same interval, 120. Okay? Now, we'll go to the next and last question in this activity, which is complete the following table computing profits to the nearest $1 million. Of course, I already computed these values. You just plug in the X in the profit expression obtained in the previous question, and you compute. Okay, you will obtain the following values. So for 1, you obtain P equals minus $69. For X equals 4, you obtain $63. For X equals 8, you will obtain $155. For X equals 12, you will obtain $151. For X equals 16, you will obtain 113. And the last value, for X equals 20, you will obtain a profit of minus 145. And here I have a quick comment. For these two values, which are negative, it's not a profit, it's a loss. It means that your cost is greater than your revenues, okay? So be careful. The profit may be negative or positive. If it's negative, we will call it a loss. If it's positive, we'll call it a profit. Thank you for your attention and see you in the next videos.